So last time we were here, we looked at that sample experiment where the student was comparing photos. One's photo where the person was smiling, one photo where they weren't smiling, right? And then students, year 9 students, were asked to judge the age of the person. So remember, what was the treatment variable then? Smiling, right? There was one picture where it wasn't. That was the control. One with the smile, that's the treatment. Okay? And what was the response variable? The age, right? What age the person guessed that they were. Okay? Excellent. Good deal. Now, so we got there and we went to some data, and that data looked like this. You don't mind if it's a little messy there, right? So smiling and not smiling, we got all of those different data points, those different ages. And so I asked you to create some graphs from that using NZ Grapher, being able to put those in. Did you have any trouble entering the data?
No.
Okay, so and you got a good graph, good results from it, for being able to make sure that you had 2 columns, right? And making sure that you put in not smiling and smiling, and then all the different age guesses. Okay, how did the data look? How did the graphs come out?
Pretty similar.
Like that.
Very close.
Excellent. So they were pretty similar. Okay, so all right. So what we're going to do is then we're going to look and analyze the data. So if you don't have it, just look on with someone else who's close by, so you can see the graph. I have a graph of this. Actually, we'll just go straight to that so that you can see what they look like. Okay. And we can see, here is the graph of that particular data from the experiment, the sample experiment, the page that was turned in. Does yours look fairly similar? Okay. And did you do the randomization so that you got the 1,000 different?
I just did this right now.
Okay. Looks pretty much like it to me, right? Okay.
Wait, is there
How's it
2
look?
options? It would be median or mean. Which one would you do? Median?
You could do either one and then compare and make a comparison of it. That would be a difference between, really good and just okay. So the more data points that you use, the more statistical knowledge that you use, compare the means, compare the medians, right? Because the more you use, the better you're going to be in the assessment. All right. Okay. So how did it go? That exercise was really just about being able to put it into NZ Grapher and get the correct data out. Because if you didn't use the numerical value first and then you didn't put in smiling and not smiling, then your data could come out or the graph would not come out. Okay.
Because like the smiling is small, the smiling is bigger, and then the not smiling is smaller, mine's smiling is smaller, not smiling is smaller.
So the results of the test were displayed using the graphs. They have the box and whiskers there, and then the chart talking about the medians, the difference between the medians, smiling and not smiling. So what can you conclude then about these pictures, this data?
Inconclusive.
You don't think you could draw a very good conclusion? Because if you look at it, it says 45% of the estimates produced by random allocation were at least as far from zero as the observed estimates. So when you're looking at the two different pictures, it was really not a huge amount of difference between the two, was there?
No.
So we can conclude that from this particular sample anyway, the smiling photograph wasn't any better at helping you predict the age than the one not smiling. But again, remember we talked about there were some real issues with this particular experiment, right?
Yeah.
For example,
They did it all in the same room and people
all in the same room, so everybody knew what everybody else said, right?
I didn't know that.
They just mentioned it earlier, right? We talked about that. And then, so she was that was part of her problem. She said she did it all in the same room, so she was afraid that people heard what they said. It was from that first part of her report. But it was really good in the report that she did recognize that as an issue, right? Then what else was it that we thought was a big problem? Who'd she use a picture of? Right, a very well-known celebrity. So much for well-known, huh? Very well-known celebrity who all right, who people might know something about. So that might skew the data, yeah? Okay? So if you were doing this experiment, maybe just take pictures of random people and do it, right? It would be better to have them in exactly the same clothes and exactly the same everything, wouldn't it? With the only difference being the facial expression, perhaps. Who knows? All right. Well, let's look at... All right, guys, focus. So let's look at the conclusion here and what they said. So there was a summary given. A difference of 0.5 or more comes up 457 times out of the 1,000. So the results, were the results pretty consistent, even though you did the 1,000 to just the one little experiment that she did? Yeah, their differences weren't too bad. Too different. Okay? And remember, you were also supposed to look at the probability. And did anybody look at the probability? Got that when you did the randomization?
Say that 457 times out of the 1,000 is the difference of 0.5.
When she did the re-randomization part, that's where you get that. Right? You push the button and
502.
Okay? It's random.
Oh yeah. Whoop.
So yours is never going to be exactly.
I was like,
Right? It's a random it's a random computer generation. So it shouldn't be exactly 457. What was the probability when you did that? It should have given you the probability of something in a percent.
With that graph.
0.52.
On yours?
It would be like 50.2 then.
Okay.
I'm not very good at this.
For the probability reading from the graph?
Yes, and he equals 502 divided by 1,000 is 0.52.
0.52 translated into a percentage is?
50.2.
All right. So, if you have a 50% probability that it would happen anyway, that the guesses would be the same anyway, then what can you conclude about this entire experiment? Remember that if it's above what percent? 10, then your results are probably going to be, it's pure chance anyway, isn't it?
Yeah.
So if you were getting probabilities in the 50s, then what can you conclude about this entire experiment?
Chance.
Right. The whole thing is just chance, right? So there's not showing any direct correlations at all. We can't make any inferences at all. So look at the conclusion. Overall, I see that there's not significant. Let me try this word again. Sufficient evidence. I can't speak English. To support the claim that people who were asked to estimate the age of a person who's smiling will give a different estimate than those asked looking at the same person who's not smiling. Okay, do you agree with that conclusion? Okay. Then she gave an appendix, the data, right? Look at the way she gave the raw data. That is very important if you want to be up, right? This is a low excellence one, right? So you make sure that you really make sure that the raw data is given neatly and organized so that it can be readable.
Oh, I remember that.
All right.
And I just ended up cutting out half the data because it was too long.
Okay. So those of you who did the inference paper last time, did y'all do inference in year 12?
Yeah.
Some of you did. Some of you might have done the
That's
graphing.
similar to the-
So it's exactly the same thing, except that what happened last time? Did you have to go out and do an experiment? No. They gave you a data set, and you just used that data set. So pretty much what we just did when I sent you home with these, right? You had a data set. All you had to do was write it up. So it's the same types of ideas that were important in that paper are important here. Okay? Now, okay? So you're going to read in your workbook, you're going to read pages 23 through 26, okay? And then I want you to look through some of those experiments. Guys, look through some of those experiments that they give you, and let's select one that we'll do in the class. All right? So think about which one you want to do, and we'll just pick one. We'll just have a little vote, or if maybe someone feels very strongly that they do or do not want to do one or the other, and then we'll pick one of those so we can actually gather some data and practice that. And then we'll run an analysis on it, etc. Okay? So there you go.